Have you ever wondered why Venus, despite being in the habitable zone, turned into a hot and uninhabitable planet, while Earth did not? Our celestial neighbor, Venus, is a fascinating study in contrasts. Although it orbits comfortably within the habitable, or Goldilocks, zone of our solar system, its current state is anything but habitable. Venus, often referred to as Earth's hot little sister, presents a curious paradox. The second planet from the Sun, Venus lies in an area where conditions should theoretically be just right for life as we know it. Yet the reality is starkly different. With surface temperatures averaging an inhospitable 450 degrees Celsius, it is hot enough to melt lead. This is a far cry from the temperate, idyllic conditions we associate with life. So what makes Venus so different? The primary culprit is its dense carbon dioxide atmosphere. This thick blanket of CO2, 90 times denser than Earth's atmosphere, creates a potent greenhouse effect. It traps the sun's heat, turning Venus into a pressure cooker and making it the hottest planet in our solar system, even hotter than Mercury, which is closer to the sun. Interestingly, it wasn't always this way. There's compelling evidence to suggest that Venus was once a temperate and humid world, much like our own planet. In fact, it's possible that Venus, with its mild climate and potential for liquid water, was once habitable. Yet, something catastrophic happened that transformed Venus from a potentially life-supporting world into the acidic, scorching inferno it is today. The question is, what exactly caused this dramatic shift? And why did Earth, despite facing similar conditions, manage to avoid a similar fate? So, how did Venus transform from a potentially habitable world to an acidic greenhouse? As we delve into the theories, we'll explore the role of massive volcanic eruptions, the impact they had on the planet's atmosphere, and how Earth managed to dodge the bullet that is a runaway greenhouse effect. This is the curious case of Venus and Earth. Researchers point to one major culprit for Venus's transformation: volcanism. This term might sound explosive, and well, that's because it is. Volcanism refers to the eruption of molten rock onto the surface of a planet, along with the release of gases and ash. This process is not unique to our planet. It's a universal phenomenon. Now let's talk about Venus. This hot little sister of Earth experienced volcanic activity that lasted hundreds to thousands of centuries. Just imagine that. This prolonged and intense activity ejected massive amounts of material into the atmosphere, contributing to the transformation of Venus from a temperate, humid world into the acidic greenhouse it is today. The scale of these eruptions is difficult to comprehend. Imagine eruptions lasting tens of thousands or even hundreds of thousands of years. Picture more than 100,000 cubic kilometers of volcanic rock being deposited on the surface. That's enough to bury the entire state of Texas half a mile deep. These eruptions didn't just change the landscape, they likely triggered the extreme conditions we now associate with Venus. Surface temperatures average 450 degrees Celsius, and the atmosphere is 90 times as dense as Earth's. Several of these massive eruptions happening within a short geologic span may have led to a runaway greenhouse effect, initiating the planet's transition from humid and temperate to hot and dry. Interestingly, Earth has experienced similar processes. Volcanic activity has been implicated in several mass extinctions on our planet, with each event wiping out more than half of the animal life. Yet, despite these cataclysmic events, Earth has avoided the runaway greenhouse effect seen on Venus. These volcanic eruptions have left their mark on Venus, but what was their impact? In the next scene, we will delve into the aftermath of these eruptions and explore how they have shaped the planet we see today. The aftermath of these volcanic eruptions was a dramatic change in Venus's climate and atmosphere. It's fascinating to imagine how these fiery eruptions, colossal in magnitude, could have influenced the conditions we observe on Venus today. It's like an artist's palette, where molten lava and ash painted the planet's destiny. But in this case, the canvas was a world, and the brushstrokes were volcanic explosions. A key puzzle piece in this planetary transformation is the surface temperature. Venus, our neighboring planet, boasts surface temperatures averaging 450 degrees Celsius. To put that into perspective, that's hot enough to melt lead. It's a fiery furnace, hotter than the hottest oven, and this intense heat is partially credited to those ancient eruptions. But it's not just the scorching temperatures. Venus's atmosphere is denser than a thick fog, 90 times denser than Earth's atmosphere, in fact. This dense atmosphere acts like a pressure cooker, trapping heat and making the planet's surface sizzling hot. Just imagine trying to breathe in such conditions. It's like being deep underwater, except it's not water that's pressing down on you, but a heavy blanket of carbon dioxide. And what's left after these volcanic tantrums subside? Well, large fields of solidified volcanic rock now cover a staggering 80% of Venus's surface. That's like having almost the entire area of Asia covered in hardened lava. These vast lava fields are silent witnesses to Venus's tumultuous past and its volcanic fury. But here's where things get intriguing. Earth and Venus, two siblings in our solar system, experienced similar volcanic activities. Yet, their fates diverged dramatically. Earth, our home, remained a cradle of life, while Venus transformed into an inferno. These changes have made Venus a harsh and inhospitable place. But why didn't Earth suffer the same fate? If you're curious to find out, stay tuned for the next scene, where we delve into Earth's lucky escape from a possible Venus-like destiny. Earth has also witnessed its share of volcanic activity and mass extinctions, yet it remains habitable. Life on this blue planet has endured not one, not two, but at least 5 major mass extinction events since the dawn of multicellular life some 540 million years ago. Each of these cataclysmic events eradicated more than half of the animal life on the planet. A sobering thought, isn't it? Just like our hot sister Venus, our home planet experienced these extinction events primarily due to volcanic activity. These eruptions were not just your average eruptions. They were colossal, lasting tens of thousands or even hundreds of thousands of years, depositing more than 100,000 cubic kilometers of volcanic rock. That's enough to bury the entire state of Texas half a mile deep. However, despite these catastrophic events, Earth managed to dodge the bullet that Venus took full on. Our planet didn't succumb to a runaway greenhouse effect, which would have turned it into a sizzling, lifeless world. Instead, Earth continued to harbor life, allowing it to evolve and flourish into the diverse and complex biosphere we know and love today. But why? Why did Earth escape the fate of Venus? This is where the mystery deepens. The truth is, scientists are still trying to unravel the reasons behind Earth's resilience. Some suggest it may be due to the presence of plate tectonics and a robust carbon cycle. Others point to Earth's distance from the Sun, its magnetic field, or even the influence of life itself. Whatever the reasons, what's clear is that these extinction events, though devastating, were not enough to tip Earth over the edge into a Venus-like hothouse scenario. Instead, our planet has shown a remarkable ability to recover and regenerate, time and time again. The reasons for Earth's survival are still a mystery to scientists, but the comparison with Venus offers valuable insights. As we continue to study these two worlds, we gain a deeper understanding of why our home remains a haven for life, and why Venus, once possibly habitable, now stands as a warning of what could happen when a planet's climate system goes haywire. The contrast between Venus and Earth raises intriguing questions about planetary evolution and habitability. We've embarked on a cosmic journey today, delving into the mysteries of our solar system's hot little sister, Venus. Once probably habitable, Venus now boasts a scorching surface temperature averaging 450 degrees Celsius thanks to its dense carbon dioxide atmosphere. We've examined how Venus, which orbits in the habitable zone, came to this infernal state. The prime suspect, volcanism, Massive volcanic eruptions lasting hundreds to thousands of centuries ejected colossal amounts of material, transforming Venus from a potentially temperate and humid world into the acidic greenhouse it is today. These eruptions were of such a scale that they could bury the entire state of Texas half a mile deep. But the plot thickens as we've also pondered over Earth's own brush with volcanic activity. Our home planet has endured at least 5 major mass extinctions since the emergence of multicellular life about 540 million years ago. Each event wiped out more than half of the animal life on the planet. The culprit? Again, volcanism. Yet Earth did not succumb to a runaway greenhouse effect like Venus. Our blue marble managed to maintain its habitability, preserving the delicate balance that allows life to thrive. This disparity between the fates of Venus and Earth is a cosmic conundrum that continues to baffle scientists, including Dr. Michael J. Way of NASA's Goddard Institute for Space Studies in New York. So, as we summarize our journey today, we invite you to ponder over this profound mystery. Why did Earth escape the heat death that consumed Venus? What intricate mechanisms are at play that safeguard our planet from such a fate? As we continue to explore the cosmos, the tale of Venus and Earth reminds us of the delicate balance that allows life to thrive. Until next time, keep wondering, keep exploring.